Hey boys and girls, it's Mrs. Bartel back for some more math. We are now zooming along. We're on Unit 7, Lesson 8. And today is all about using our knowledge and what we know about fractions to solve word problems. So kind of like some real life problems that could probably happen. All right, before we actually start, I want you to think about what a fraction tells you. So just look at right here, boys and girls. Look at 7/8. Think about just what this would tell you. Think about what the numerator is and what the, denominator is. So I'm going to start right here with the denominator. That tells me that there are going to be 8 equal pieces, that the one whole is cut into 8 equal pieces, and each of those 8 pieces is 1/8. So that's the unit fraction, 1/8, and there are 8 of those to make up the whole. So out of that, there are 7 of them altogether. So if I had a fraction bar, I would have 7 of the 1/8 shaded, and one of them would not be. All right. Remember we talked about, I'm just kind of reviewing a little bit before we get going. We talked about when fractions have the same numerator, and when they do, I always like to think about just the unit fraction. That makes it easier for my brain. But when fractions have the same numerator, look at here, right here, what do you see happening? I see the denominator growing, getting bigger, getting larger, but I see each piece getting smaller. So as long as the numerators are the same, the larger the denominator, the smaller the fraction. Okay, we talked about that. Then we talked about denominators being the same, but numerators being different. So if you have a fraction where the denominators are the same, but the numerators are different, look at here. Let's look at 1/3 and 2/3. The numerator is different, right? Denominator's the same. Look at what 1/3 is. Look at how big that is. Now look at how big 2/3 is, right? When the denominator is the same, you can ignore it and just look just at the numerator. And the bigger the numerator, the bigger the fraction, okay? So that's just a little bit of review before today. All right, so today we are going to be drawing a lot of diagrams. If you don't have scratch paper, you need to get some. This space is not sufficient, boys and girls. I know you know from all the paper we use in the classroom that I want you using paper that can display your work and make it nice and neat. Okay, I'm not even going to look at the question on here. I just want to read the story. The shelves on Roger's bookcase are 7/8 of a yard long. LaTanya's bookcase shelves are 5/8 of a yard long. So I'm not even looking at what the question is asking me. I'm not even going to think about that yet. I just want to draw what they just said. So what I did on my paper was I drew 2 fraction bars, one on top of the other. It may look like I drew 1 bar and divided it in half horizontally. No, it's actually 2 separate bars. And I drew one for Roger and one for LaTanya. And I made a note over here on the side how long Roger's is and how long LaTanya's are. So pause the video and do that. And then when you come back, we will partition these. We will divide them equally into the pieces that we need to. All right, boys and girls, hopefully you've drawn both of those and you've written some notes to yourself. So we need to divide these into 8 equal pieces. Both of them have a denominator of 8. Both of them do. So I already kind of think I know which one's going to be the larger fraction and which one's going to be the smaller. I'm hoping you kind of have an idea about that too, because we said when the denominators are the same, you can ignore that and look just at the numerator. All right, so if we're dividing into 8 equal pieces, the first thing I'm going to do is cut these in half. I'm going to cut each half in half, so I have fourths. Then I'm going to cut each fourth in half so that I get eighths. I'm just going to double check counting too. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I'm right. So we're going to shade 7 out of the 8 for him and 5 out of the 8 for her. There's 4 and 5. Now, we don't know what the question says yet. We just drew what the story problem said at the beginning. His shelves are 7/8 of a yard long, hers are 5/8, and that's what this picture shows. So hopefully you have some prediction about what the question might be without looking at it, just like we do in class. We try to get our brains working around what it could possibly be asking us. And normally you guys come up with way better questions than they do. All right, let's look. Whose bookcase has longer shelves? And how do you know? You cannot just say, for how do you know, is Mrs. Bartell made me draw the fraction bars. You can't say that, sorry. You have to actually give mathematical reasoning. So hopefully you're gleaning that Roger's bookcase shelf is a lot longer than hers. He can fit more books on his shelf than she can. All right. How do you know his is longer? If you didn't have this picture, how would you know? Remember, when the two denominators are the same, you can simply ignore them and look at the numerator. So 7 is greater than 5. So that is what you would be writing for your answer for how do you know. When both denominators are the same, the numerator that is larger is the larger fraction. You may want to pause the video so you can be writing that. All right, number 2. Again, I already drew some fraction bars, and I cheated, guys, and I looked ahead because I didn't want to have to waste so much time on the video for you, because you can hit pause, and I can't. If I hit stop, it just stops it for some reason. Okay, so this one has an R and an L too. Rosa buys 3/4 of a pound of cheddar cheese. Lucy buys 3/8 of a pound. Again, I'm not even going to read the question yet, boys and girls. I am not. I just want to look at the amount for Rosa and the amount for Lucy. So if I'm dividing Rosa's into fourths, it's kind of like what we did up above. I'll divide it in half and divide each half in half, right? That's fourths. And hers is 3 of those. 1/4 plus 1/4 plus 1/4 is 3/4. Now, Lucy is 3/8. Now, just like what we did up here for eighths, I'm going to cut it in half. I'm going to cut each half in half. Now, I have 4 equal pieces, and then I'm going to cut each fourth in half, and that's going to give me my eighths. 1, 2, 3, 4, 5, 6, 7, 8. My 8 1/8, and I'm shading 3 of those. Okay, now here's what I'm noticing. I'm noticing that the numerators are the same this time. Just like in a unit fraction, remember it's 1, right? When the numerators are the same, the bigger the denominator, the smaller the fraction. So I'm thinking this one's larger, and it's showing me in the picture. This one's smaller. It's showing me that in my picture that I drew. So now we need to go and think about what the question is. Hopefully you're thinking about what some questions could be too. Your questions are probably better than theirs. Who buys more cheese? And explain your answer. So you should be able to pause the video, boys and girls, and you should be able to explain who buys more. Who buys more? Rosa. when you're explaining your answer, once again, you cannot say, Mrs. Bartell made me draw the fraction bars. No, you cannot. You need to talk about math. Math words have to be in your explanation. You can talk about how when the numerators are the same, the bigger the denominator, the smaller the fraction. Or you may say, when the numerators are the same, the smaller the denominator, the larger the fraction. Okay, so you may want to pause the video while you get caught up and then go ahead and resume it when you're ready for the next problem. All right, number 3. Martha baked 8/4 of a dozen of cranberry muffins. Vera baked 8/6 dozen muffins. All right, here's what I'm noticing already, boys and girls. What I remember is when we were drawing our equivalent fractions on a number line the other day, I remember when the numerator and the denominator are the same, it's one whole. So if the numerator is larger than the denominator, it's going to be larger than a whole. So on this, I'm going to use fraction circles to represent my story because it's going to be larger than one whole. And remember, boys and girls, you have to use your imagination. These circles are going to be the exact same size and same shape. Turn your imagination on right now that they really are the exact same size and same shape. So the question said, or the story said, that Martha baked 8/4. So I'm going to make these into fourths. I'm going to make these into fourths. That's what the denominator says. And I'm going to shade 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Now, that's actually 2 wholes. That's 2, and I'm going to write the word wholes, but we normally wouldn't write that word, but it's 2. So it said in the story it was 8/4 dozen cranberry muffins, so it's 2 dozen. Okay, that's how I know right there. Okay, now Vera is 8/6. Now boys and girls, 6 are a little bit harder to draw when we're doing it with circles. Remember, we've done this in class. You find the center point. We're going to draw that vertical line that's perpendicular to the bottom of your paper. Okay, just like that. And then we're going to, somebody in class said, oh, it's kind of like that peace symbol. And yes, we're going to do thirds first. And then we'll cut each third in half to get our 6. So we'll do that for both of these circles. We'll get them into 6. Remember, if you need to pause the video because I'm going too fast, you may want to do that. But I don't want to take too long on the video by waiting. So using that pause button is how you say, Mrs. Bartell, you're going too fast. Okay, so this says to shade 8 out of the 6. So here's 6 of them, all 6 of them, and then 7 and 8. So I'm only going to shade 2 on this. So I see 1 whole, and I see 2 6. So Martha has 2 dozen. Vera only has 1 2/6 dozen. This is called a mixed number. A mixed number includes a whole number and a fraction. Okay? These are just called fractions greater than a whole because the numerator is larger than the denominator. Okay, hopefully you've been thinking about what the question could be asking us. It's either going to say who baked more, who baked the least amount, how do you know? Something to that effect. Okay, let's look and read what it says. Yep, who baked fewer? Who baked the least amount? Boys and girls, hopefully you're noticing Vera is the one that baked the least amount. Now, it says to explain, how do you know? Yes, you have to explain your thinking. How do you know she baked less? How do you know? Now, you cannot just say, Mrs. Bartell made me draw the picture. And that's true, I did, and you can see it right there because you have the picture. But you can't say that. You have to use mathematical thinking, what we know about fractions. So come up here, look at your denominators, they're different, okay? Look at the numerators, boys and girls. Now, all of a sudden, when I thought about numerators and I thought about them being the same, these light bulbs just went off in my brain about unit fractions. And what do I know about unit fractions when the numerators are the same? When the numerators are the same, what do I know about what happens when the denominator gets bigger? Look at here. When the denominator is getting bigger, that means the whole is being divided into more and more pieces, and the pieces get smaller. So these have the same numerator. So the fraction with the biggest denominator is going to be the smallest. The one with the greater denominator is going to be bigger. So more or less, who has more, who has less, who has the greatest amount, who has the least amount? What do you think? And how do you know? Pause the video and go ahead and write about what your answer is. All right, boys and girls, here we go. On to our next problem. Lester walks 3/4 of a mile to school. Poor Lester. I hope it wasn't in the snow and in the rain and he had to leave the night before because it was all uphill. Lester walks 3/4 of a mile to school. Bert says he walks farther because he goes 6/8 of a mile. Okay, boys and girls, you should have 2 fraction bars, 2 of them. And I would jot some notes over for Lester and then for Bert. He went 3/4, Bert went 6/8. Go ahead and pause the video, draw your 2 fraction bars, and jot your notes. Okay, hopefully you're ready. We are going to partition or divide the first fraction bar into 4 equal pieces. Here we go. We're going to cut it in half, and then we're going to cut each half in half, and then that will be 4 equal pieces. Now he went 3, so we have to shade in 3 of those. 3 of the 1/4. 1/4 plus 1/4 plus 1/4 is 3/4. There we go. Now, Bert went 6/8. So remember how we made 8s. We're going to cut it in half, cut each half into half, and then we'll have our quarters, our fourths. And then we'll cut each 4th in half to get our 8s. Okay? There's 2, 4, 6, 8 equal pieces. Okay? Now he walked 6/8. So there we go. Bert says he walks farther. Oh, I think I might know why he thinks he walks farther. I want you to think about why he might say that. Look at the numbers that make up 3/4. Look at the numbers, or the digits rather, that make up 6/8. So I think what Bert is thinking is that 6 is bigger than 3 and 8 is bigger than 4. That's kind of what I think he's thinking. So, do you think that Bert walked farther? What do you think? Look at the illustration. Look at your 2 fraction bars. Did Bert walk farther? Hopefully you're coming up with the big fat no. Boys and girls, this fraction is the exact same as that fraction. What do we call those? What do we call it when both fractions are the same and they equal each other? They are called equivalent. So, for your answer on here, let's see what it says. Yes. Is Bert's statement correct? Big fat no. Explain your answer. So you're going to explain that 3/4 is equivalent or equal to 6/8. All right? Go ahead and pause your video and get that done. All right, boys and girls, back for number 5. Jack's family has a pickup truck that weighs 9/4 of a ton. Now, what I'm noticing already, boys and girls, is that the numerator is greater than 4. That means it's going to be bigger than one whole. The fraction is going to be greater than a whole. Ruth's family has a car that weighs 9/8 of a ton. Once again, greater than a whole. Okay, so on my paper, because these are greater than a whole, I didn't draw fraction bars. I drew fraction circles. Okay, and for Jack, I wrote 9/4. And if you think 4, 8, 12, so 4 and 8, that's the 2 circles wouldn't be enough. I am going to need 3 because each one has to be divided into 4. And if I just did 2, that would be 8, not enough. Now Ron, is it Ron? I get mixed up on the names. Nope, it's Ruth. Okay, 9/8. So we're going to make this into 8 pieces, and then I would only need 1/8 more. So I'm only drawing 2. Now remember, boys and girls, these circles are exactly the same size and same shape because they have to be. So turn your imagination on. All right, so we're going to come over here, and we're going to divide Jack's into 4ths. Boys and girls, you may want to just go ahead and pause your video and put your center dot in and divide them into 4ths. And remember, if we were going to make 8ths, which we're going to do over here, you are going to cut each 4th in half. Pause your video and do that. I'm going to keep drawing too, but I may be drawing a little bit faster than you are, so pause. By the way, when you are doing 4ths, if you do it like this, right, the 4ths, when you want to do your 8ths, instead of doing each quarter in half, you can draw your line all the way like that, all the way through, okay? So we're going to do our 4ths. So once again, to make the 8ths, you can draw your, it's almost like putting an X through it. And remember, boys and girls, we are pretending that every single section is equal to the others. Okay, you have to use a little bit of imagination. All right, once you're done drawing, I want you to pause and I want you to shade however many pieces it tells you. So this tells me to shade 9. This one tells me to shade 9 as well. So 4, 8, 9. My shading is not the best. On this, I'm shading all 8 and then just one more. Now, I want to point out something to you, and we haven't really talked about this yet. We've talked about fractions greater than a whole, but we have not talked about something called mixed numbers. Although in our math in minutes, we may have talked about mixed numbers, but just kind of briefly, not to where you really probably had a lot of understanding. But I want you to think about how many holes you see that are fully shaded here. There's 2 of them, right? There's 2. And then what is left here? 1/4. So this is 2 and 1/4. That's what 9/4 represents. This 9/4 fraction greater than a whole actually represents this mixed number. A mixed number is a number, a whole number, plus part of a fraction. So over here for Ron, Ruth, hers was 1 whole and 1/8. And I think we were talking about tons, if I'm correct. So again, this is a mixed number. It's the whole plus 1 more 1/8. Okay? So let's look at what the question was. Oh, I didn't read the question yet. Maybe you did. I'm not sure. I'm thinking the question's probably going to be like, whose truck weighs more? Whose weighs the least? How do you know? Something like that. Oh, it's a car and a pickup. Sorry, guys. Okay, Jack's pickup truck weighs this much. The car weighs this much. Okay, is the pickup truck heavier or is the car heavier? Look at here. Is the pickup truck heavier or is the car heavier? This is the pickup and this is the car. Which weighs more? Which one's heavier? Hopefully you're coming up with the pickup truck being heavier. How do you know? You cannot just say that my illustration told me so, even though that is true, even though it is. I want you to look up here and think about what we know about fractions. Boys and girls, look at the numerators. They are the same. Think about unit fractions. They all have a 1. What do we know about unit fractions? They all have a 1 in the numerator. So look at the denominators. When the numerators are the same, the bigger the denominator, the smaller the fraction. So what do you think here? The bigger the denominator, the smaller the fraction. So this is going to be greater. And it is. And you can see it's 2 wholes plus a 4th. And this is just 1 whole plus an 8th. Hopefully that makes sense, and you're going to explain that. So pause your video to do your explanations, boys and girls. And then we will get on to our next problem, which is number 6. All right, this problem talks about Rusty painting a mural. Now, boys and girls, that mural, we have several beautiful murals that Mrs. Farmer had painted for us. And one of them is that Crestmont one as we walk down to the multi-purpose room. And then the other one is that beautiful one that's so vibrant in color. And it's the one that shows the master symbol and talks about what a master school is. And that's on our way to recess. So just so you have a visual about what a mural is. So Rusty paints a mural for the school. Now he painted 5/6 of it. So I'm going to make a note over here, Rusty 5/6. Now the question, well, actually I'm not even going to read the question yet. I'm going to make a fraction bar and I'm going to divide it into 6 equal pieces. So I'm going to cut it in half and then I'm going to cut each half into thirds. Now, boys and girls, please think that please remember these are the exact same size and shape. Don't judge me that this is bigger. It's not supposed to be. They're supposed to be exactly the same size and shape, okay? So he did 5/6. So 1, 2, 3, 4, 5. There we go. 5/6. Now, if you didn't want to do it like this, you could have done a circle. You could have done your circle. Put your center point and shaded 5/6. So you could have done it that way too, okay? So either way, nobody says a mural has to be a rectangular shape. All right, he painted this mural. He painted 5/6 of it. And you can tell I have 5/6 here and 5/6 here, so either way. Now the question says, has he painted more than half of it? And then you have to explain your answer. Hint, find an equivalent fraction in sixths for 3, or in 6 for 1/2. Well, since I have my fraction bar here, I'm going to make another bar that's exactly the same size and shape, and I'm going to cut it in half. 1/2 and 1/2. Boys and girls, he colored 5/6. The question says, has he painted more than half? Hopefully you're seeing that yes, indeed, he did paint more than half. He did. Now, they want you to explain your answer. So you're going to have to explain that 5/6 is greater than 1/2. Now, the hint for your explanation, they gave you one. They told you to find an equivalent fraction in 6 for 1/2. Boys and girls, here's my 1/2 and 1/2, and I'm going to make these into 6. 1, 2, 3, 4, 5, 6. Boys and girls, how many 6 is 1/2? Hopefully you're seeing 1/2 is equivalent to 3/6. This is going to help you with your explanation. If 1/2 is equivalent to 3/6, then by all means, he definitely shaded more, or painted rather, more than 1/2, because he painted 5/6. Remember, when the denominators are the same, you look at the numerators. Okay, that's why they wanted you to find an equivalent fraction, something with the same denominator. Because when the denominators are the same, you look at the numerators, and the one that's larger is going to be the larger fraction. Okay, that's it for that problem. And now you have some problems on the back to do as well. This is a lot of work for one day. Hopefully you're not doing all of these problems. Hopefully you're like maybe doing odds. This is a lot, boys and girls. In fact, on the back, I would definitely recommend, like, I don't know if you've already done all the ones on the front following along with me or not. I know I said to your parents over and over, don't be doing every single problem because you'll be here all day, and we don't want that. But I would definitely, if you have done all the ones on the front, don't do all the ones on the back, okay? Maybe pick 1 or 2, and that's it. Don't do them all, too much. But because I do know I have overachievers, I am going to go over all of them, because I know that we will have people that are trying to do them all and they may need some help. So you may have to fast forward the video a little bit, okay? Sorry about that. All right. Oh, I forgot to number this problem. That's important. That was number 6. Remember to always number your work so it's nice and organized. Okay. Number 7. Pearl used 3/3 of a yard. Hey, I know that that's a whole. Pearl, 3/3, which really is 1 whole. Julia made her pillow from 4/4 of a yard of fabric. Now guess what? That's 1 whole as well. They both paid $5 for a yard of fabric. Who paid more for their fabric? It's $5 for each yard. 3/3 is a whole. That's a yard. So that's $5. 4/4 is a whole. That's a whole yard. So that's $5. Now, boys and girls, who paid more and how do you know? Who paid more and how do you know? Hopefully you're seeing that they both paid the same amount. Now, if you're not understanding that 3/3 is a whole and 4/4 is a whole, I would recommend drawing 2 fraction bars that are exactly the same. Now for the first one though, we're going to cut it into 3 equal pieces. And remember, they're all going to be shaded. On the next one, we're going to cut it into 4 equal pieces. And of course, it's all going to be shaded. So do you see there that those are both 1 whole? Who paid more? Hopefully you're seeing they both paid the same. Now, it's asking how you know. And you cannot just say, I drew a picture. You cannot. You certainly can talk about how 3/3 and 4/4 are both 1 wholes, because when the numerators and the denominators are exactly the same, that equals 1 whole. So you can use that reasoning if you want. All right, moving on to number 8. Number 8. Remember, boys and girls, I'm trying to move a little bit fast in the video. You are going to have to be pausing. At Banata's Bakery, 2 different recipes are used for wheat bread. A round loaf has 5/2 cups of wheat flour. For a long loaf, it has 7/2 cups of wheat flour. Now, boys and girls, what I'm noticing is that the denominators are exactly the same. And I'm also noticing that these are fractions that are greater than a whole. So for the purposes of this, I want you to be drawing circles. So, and we're going to cut them in half because the denominators say 2. So 1, 2, 3, 4. Remember, these circles are exactly the same, right? Now we're going to write our mixed number. This is 1 whole, 2 wholes, and a half. So this is 2½ cups. Over here, we're going to do the same thing. We're going to draw our circles. Now remember, this circle's the same size as that. All these circles are the same size because the whole has to be the same. 1, 2, 3, 4, 5, 6. Still don't have enough. 7. Now remember, boys and girls, the wholes are the same, right? Okay, turn your little imagination on for me. This is 1, 2, 3½ cups. These are the mixed numbers. You didn't have to come up with the mixed numbers, but I think it's important to introduce that. All you really needed to do was look at the denominators and see that they're the same. And when denominators are the same, you look at the numerator. The greater the numerator, the greater the fraction. So hopefully you're noticing that this is the most flour. This takes, a round loaf does not take as much as the long loaf. Now the question says, for which kind of bread is more wheat flour used? Hopefully you can pause the video and come up with your answer and give some explanation for it. You cannot just say, I drew the picture. You have to talk about the denominators being the same, and when denominators are the same, the fraction with the greater numerator is going to be larger. All right, boys and girls, pause your video and get that done. Then we'll move on to number 9 here. Number 9, Deanna's water bottle can hold 2/5 of a liter. Now, I know you know a water bottle looks vertical, but I'm going to draw a fraction bar that looks like this. And dividing it into 5 equal pieces, that's a little tricky. Here would be half. Let's see, 1, there's 2, 3, 1, 2, 3, 4, 5. Oh, those look pretty good. This is just, you have to eyeball it, boys and girls. There's no perfection way to do this. It can just be trial and error. So this is Dina's, and it holds 2/5 of a liter, okay? Remember, liters are like those big giant soda bottles, although it's half of that big giant A&W soda bottle I have in the classroom. It's half of that, because that's a 2-liter bottle. Okay, so there's 2/5 of a liter. That's how much hers holds. Now, John's water bottle holds 5/2. 5/2. Oh boy. So John is 5/2. Guess what? This is greater than a whole. So if I were to draw, and remember, it has to be the same size as this one, right? The bars have to be the same. There's 2. 3, 4. Wow, he must have a giant, he must have the bottle that that Kaylee had that broke on the ground, and then the custodian never came, and we had to use like an entire brand new roll of paper towels and kill a tree to clean up the water. That was a nightmare, Kaylee. You were so good about that. You had patience. Oh boy, that was so scary. And then Lily almost tripped. All right, so here's this water bottle with 2/5. Here's his water bottle, ginormous. It has 5 halves. Now, do you see that the holes are the same, right? So this is 1 hole, 2 holes, 2.5. This is 2.5 liters. That's a mixed number, okay? This is only 2/5 of 1 liter. So let's look at the question. Whose water bottle holds more? How do you know? You cannot just say that you had to draw a picture. Boys and girls, what you could talk about it is the fact that this is 2/5. That's not even a whole. But right down here, you can tell this is greater than 1 whole because there's the numerator is 5. It's greater than the whole. Okay? That'll be your explanation for that one. So you're going to want to pause and get your thinking wrapped around that. All right, number 10 talks about Andy, Lou, and Carlos. Andy, 3/3. Lou, 3/4. Carlos, 3/6. Oh, it says not in this order. Uh-oh. All right. Not in that order. Didn't read that. Let's draw some pictures. How about that? So we're going to draw, I think we'll do circles. We'll pretend they're the same. Okay, since I lined them up like this, we'll pretend all 3 circles are the same exact size and the same exact shape. Okay? Put your center dot in. So we're going to divide this one into thirds. This one will be divided into fourths. This one will be divided into 6. So remember to do that. We'll do thirds, and then we'll cut each third in half. Okay, and that'll give us our 6 equal pieces. Boys and girls, we're imagining that these are exactly cut perfectly. They're not, but for the sake of what we need to do and moving on with our whole life, we have to. Boys and girls, look at 3/3. That's 1 whole. That's 1 whole. So if we were shading 3/4, that's what that would look like there. And 3/6. What do you notice about 3/6? Can you think of an equivalent fraction right now for that? It's the same as 3/6. It's really like having half, right? And if we were going to change the half into fourths, if you changed a half into fourths, what would it be? 2/4. Ooh, we just created a little equivalence chain over here. Okay, so we have Andy, Lou, and Carlos, not in that order, have this amount of pencils, this amount of pencils, and this amount of pencils. Now, it says Andy has the fewest pencils. Which one of these is the least amount of pencils? Think to yourself, which one is the least amount? It also says Lou has the most pencils. So, hopefully you're figuring out Andy, Lou has the most. Who would this be? Carlos, right? Yep. How many pencils does each boy have? And then explain. Okay. So now remember, these are dozens. This is in a dozen. How much is a dozen? A dozen is 12. So this person has the whole dozen. So how many pencils is that? Think about that. How many pencils is a dozen? That's 12 pencils here. This is pretty hard, guys. All right, the next easiest one, we decided 3/6 is a half. So what's a half of a dozen, half of 12. Think about that. That is 6, right? Half of 12. Okay. Now comes the hard part, boys and girls. It's not actually that hard if you think about it. 3/4. So we would know that this and this are 6. 3, 6, 9, 12. The whole thing would be 12, and it's divided into 4 equal parts. So 12 divided by 4 is, or 12 divided by 4 is 3. Each of these is 3. 3, 6, 9, 12, but he only has 3 shaded. So 3, 6, 9. So this is 9 pencils. This is this is easier. This I would expect you to be able to do. This I would be able to expect you to figure out that half of the dozen. This is very difficult, boys and girls. Hopefully you paused it. This is 9 pencils. So they want you to figure out who has the fewest, who has the most, how many pencils does each boy have, and explain. So if you're talking about a whole dozen, that would be 12. Over here for Andy, we're talking about he has 3/6, which is the same as a half of a dozen. So that's 6. Right here, if you take a dozen and you divide that 12 into 4 equal parts, take the number 12 and divide it into 4 equal parts. How much is each part going to equal? What number times 4 is 12? It's 3. Each of these is 3, and we had to shade 3 of them. 3, 3, 3, 3. 3, 6, 9, 12. Yep, that whole thing equals 12. So we only shaded 3, so that's 9 pencils. Hopefully that makes sense, boys and girls. Alrighty, good job, guys, persevering. Bye.